All right, section 4 in the review for 5.1, 6.1, and 6.2. Number 1, solve each radical equation, check for extraneous solutions. All right, so we're going to solve, basically on these problems, we want to isolate the radical, which in that case, we're going to isolate the cube root, and then we'll raise everything to the third power. So, kind of like the previous problems, we're going to just get that by itself. So we're going to subtract 2, get a cube root of x minus 4, which equals negative 3. And now we think about how can I get rid of this cubed, right? So if I'm taking a cube root of something, the inverse of that is raising it to the third power or cubing it. So that means we take each side and we're going to raise it to the 3. Take this and raise both sides to the 3. And that's going to give us, in this case, it'll just give us whatever's inside that's going to come out, right? So I'm going to take this x minus 4 is just going to pop out. And negative 3 cubed is negative 27. And if I add 4 to both sides, I'm going to get x negative 23. Now it says to check for extraneous solutions. Essentially, that just means I'm gonna take this, I'm gonna plug it back into my original equation and just make sure things are making sense here. That it doesn't actually give me an error or some kind of domain error, or just when you plug it in and it doesn't even work. It doesn't even give you a true statement. And so in this case, this one there is no extraneous solutions. You can check it, but everything is good with that. Okay, part B. We're going to go ahead and do the same thing. So we're going to get the square root by itself. I'm going to get this by itself. That means we're going to subtract 10 to start. So I'm going to take that. I'm going to get the square root of 2x plus 1, and that equals 3. Once I isolate that, then I have to do the inverse. The inverse of taking a square root is squaring. So I'm going to take that, and I'm going to square both sides. This is going to give me just now 2x plus 1 equals 9. So I can subtract 1 from both sides. So 2x equals 8, and x equals 4. Again, check for extraneous solutions. That means let's plug it back in here and just make sure it works. And it does. Everything should be fine there. You're going to have 13 equals 13, and there should be no problems there. All right, part C. If you look at part C, we're going to isolate the radical again. So we're going to subtract 4. We're going to get the 4th root of x minus 3 equals 2. If we take a inverse here of a 4th root, then we're going to raise everything to the 4th power. So that means everything inside of that radical is going to come out. So I'm going to have an x minus 3 that comes out, and 2 to the 4th is 16. So then if I add 3 to both sides, and I'm going to get x equals 19 is my answer. Again, check for extraneous solutions. There is no extraneous solutions in here. You can plug it in, and you're going to see that the 4th root of 19 minus 3 is going to be 2. 4 plus 2 is 6, so that checks out. All right, and then part D. Same old, same old. We're going to take this. We're going to get the square root of 9x by itself. To do that, we're going to divide by the 10 to get it by itself. So I'm going to have the square root of 9x equals 6. If I take an inverse, I'm going to square both sides, and that's going to give me 9x equals 36. And then I can divide by 9 to get x all by itself. X equals 4. Check for any extraneous solutions. and that again is going to be fine. No extraneous solutions there. All right, keep it going. Number 2, it says multiply and simplify each radical expression. All right, so the first thing in these problems is we're going to combine them first. We're going to combine those two things together. So we have a 6. I'm going to leave that 6 out here. But then we're going to multiply these radicals together. So since I have these two radicals and they're both square roots, right? The index is not written here, right? Since it's not written, I can safely assume that is a square root because that's a common radical to use. Since they're the same radical or the same index, we can multiply those together and combine those. So this is going to become 8 times 2 is 16. And then a to the 9th times a to the 1st power is going to be a to the 10th. And then b cubed times b to the 5th is b to the 8th. All right, so now that I multiply these radicals together, again, I can do that because they're the same index. Once I multiply them together, now I want to reduce them, right? So we go back to that problem of, okay, what kind of perfect squares do I have in here? What is the square root of 16? What is the square root of a to the 10th? And what is the square root of b to the 8th? So we think about how many squares I have in this problem, or how can I rewrite this? So I showed you guys a bunch of different ways to think about that. I'm going to show you kind of the same way as before, but just a little bit quicker maybe. So basically I want to write these as things to the 2nd power, right? So 16 I know is 4 squared, right? A to the 10th, how many a squares can I get in a to the 10th? Well, I know I can get 5 of them, right? I know that if I have a to the 5th, right, and I raise that to the 2, I can kind of factor it out like that, right? So I can have a squared times a squared times a squared times a squared, and I can write it out like that. And then b to the 8th, right? How many b squareds can I have in there? Well, I know I can do 4. So this is going to be b to the 4th. And again, this is all squared. B to the 8th is the exact same thing as this, because I know 4 times 2 is 8. But now when I do this problem, and I think about, hey, what can I pull out of here? Well, basically anything that is squared inside the radical can come out. Well, there's all my squares. Right? So I can pull out all the red things. I have a 6 that's already out. I know I can pull out a 4 because the square root of 16 is 4. I know I can pull out a to the 5th because I know that the square root of a to the 10th is a to the 5th. And then the square root of b to the 8th, I know I can pull out this b to the 4th right there. So there's several different ways you can visualize that or think about what you're doing there. Even if you just divide the exponent by the index, you're going to get the same thing. 10 divided by 2, 10 divided by 2 is going to give me that 5. 8 divided by 2 is going to give me that 4. Okay. The only problem would come in is if you have a remainder there, then you have to keep some terms inside the radical. But this one comes out nice and clean. So this is 24 a to the 5th, b to the 4th. Part B, we are multiplying these radicals together. So I have, this. It almost looks like it's subtraction there, but we have a multiply right there. So it's multiplied by this radical right here. So again, we can merge, we can multiply these radicals together so long as we have the exact same index here, which we do. They're both cube roots, so that's good. So we can put this all together in one. So I'm going to have the numbers first. I'm going to have 5 times negative 2. That's going to give me a negative 10. And then I'm going to have the cube root of, and now I'm going to multiply everything inside. So those yellow things. So if I look at that, I have 4 times 16, which is 64. So this will be 64. I have c to the 5th times c to the 3rd, which is c to the 8th. And I have d to the 4th times d to the 11, which is d to the 15th. So there's my answer so far. But again, we're going to simplify this down. So my index here is a cube, or not a cube, but a third root, or a cube root. And I want to see, all right, how many perfect cubes can I make of all these terms right here? So the first one's 64, right? So I'm going to reduce this. I have -10, and then I'm going to factor this out in such a way where I can see how many I can pull out. Well, 64 is a perfect cube. Okay, think about what that equals. All right, so this is going to be 4 cubed. Cube root of 64 is 4. So I'm going to write that as 4 cubed. I know it's going to come out as a 4, but I'm going to write it as 4 cubed. And then c to the 8th. You know, how many c cubes do I have in c to the 8th? I'll just think about, 8 divided by 3. 3 goes into 8 twice, and I have then 2 remainder. But if I write that out, sometimes I just like writing it out the old-fashioned way. So I got c cubed, times, and then I have c squared left over, right? Then I look at the d to the 15th. How many d cubes do I have there? Well, 15 divided by 3 is 5. So I'm going to have d to the 5th come out, but let me be consistent here, and I'm going to have 5 d cubes. Okay. So what happens? Everything here is going to come out. So I have a -10, and this will be times a 4 comes out. I have 2 c's that come out, so that's going to be c squared. And I have 1, 2, 3, 4, 5 d's that come out, so that'll be d to the 5th. And then what's left over? What's left over is just this c squared is the only thing that's left over there. So then I have times the cube root of c squared. So my final answer is -40 c squared d to the 5th times the cube root of c squared. That is all.